Alright, so here we go. I am going to continue on development on my NVIDIA Nano right here. And in the last video that we made about a week ago, we were hooking up this speaker to it and getting it to be able to recognize the the words which I was saying. So I was talking into it, and it was being transcribed, and we were seeing that. So today, hopefully, we are going to be able to move this project forward a little bit more. The idea that I have is now that we're able to get our voice to text, it's time to go kind of the other way around. So trying to see if we're able to go from text out to voice and use this as a speaker. So do the other way around and see if we're able to do that. So let's start this and see what we can accomplish. So power it up and all right, there we go. Okay, and plug it in. Okay, so there we go. I'm gonna make my I am going to make myself a little bit smaller. Here we are. And let's try to get the. So I can't. I remember that we were trying to swap over the boot segment, or not really the boot segment. Hold on. We were trying to swap over from SD to SSD. So we have a micro SD card, and that's where we were keeping everything: the kernel, the file system, all of that. And what I did in the last video was plug in the SSD, and now I needed to be able to swap over from the micro SD to the SSD. And the way that we did this, I'm saying it to myself right now so that I can remember what we did a week ago. So what I did was I first had to go in and we were looking at the different uh, order of boot sequence, like how things are actually booting up. When power is applied, what actually starts up? And there was this thing called UEFI, and then EFI. Okay, so UEFI goes and it looks to find the like it goes to UEFI goes and tries to find a EFI partitioned uh no U the UEFI tries to go and it searches all of its connected block storage devices that it's physically connected to, and then it checks each of the partitions to see if they're of type EFI. If it does, then it uses its sequence, like order of precedence, to determine, okay, so I'm gonna boot from whatever, a micro SD card above an SD card, something like that, right? So in this case, we see that here's a partition that is EFI. So we'll come here, and this in here, there's going to be a script, and that script looks for a like configuration file that has the root file system. So this is kind of starting up the actual OS and everything, and it wants to know, like, where do I actually put that? And normally in the past we had this partition here, which was had the file system and has the configuration in here. And that configuration has a line which says root equals and then the location where we want to put the file system, right? So what we needed to do was we have our new block storage device. This is the SSD, so the NVMe SSD right here. And I first needed to partition it, and so we used like fdisk or something like that. We used fdisk to partition this block storage device, and that now that has the partition table at the top, and then the single partition. We only did one partition of this SSD. Okay, great. And then what we did is we went in and said, hey, this partition here, you're of type exit4. So each of those partitions can have different file types. Like this one, I believe, was FAT32. But Linux file systems are exit4, so we needed to make this partition, I guess this, I should say, not, anyways. So that particular partition to be exit4. Now, once we did that, we needed to copy over everything. Okay, so once we copied everything over, once we copied everything over, then what? We needed to copy it over in a specific way because previously in the past I tried using DD and that actually didn't work very well. I was running into a whole bunch of problems. This time we used, I forget which, which method we used for copying the files over. rsync. rsync, that's what it was called. We used rsync. And so essentially what I did was I copied over the entire data which was in here, in this partition, and moved it over to be this partition, okay? And then I changed the configuration file to say root is equal to this partition's like unique global identifier. And then when we power things up, the UEFI comes alive. It looks at all of its storage devices. It still sees this boot configuration here in the micro SD card block storage device. It boots it. It looks for the configuration file, which I think is still actually in here. And then it will say, like, okay, in this configuration file, it says root files or root equals and then the partition ID. So it looks for that partition ID, finds that it's this one, and then has this as the root file system. Comes alive, and that's where we are. So we're booted from the SSD. Okay, so now what I should be able to do is load, or like come in here, Jetson, make sure that we are good. Okay, so here we are. We are back. And one other point of note is so in the last video on Saturday, or sorry, on Sunday and Saturday, I was kind of complaining about like, why is my memory so bad? Why am I unable to focus? Why am I unable to like, I was like trying to observe this about myself. I was like, this feels weird. Like I cannot remember anything. So I decided on Monday, like I'm not going to take any supplements. So I didn't take any supplements Monday, Tuesday, Wednesday, Thursday, Friday, or today, right? So I haven't taken uh any of the supplements all 5 or 6 days now. So for the first 3 days, I was like completely drained, tired, unable to focus. It felt like I would be trying, people would talk to me, and I would just be like zoned out almost. Like I could hear the noise, but I couldn't understand what they were saying. And I was just like I couldn't understand it. It's kind of like that, the idea of trying to do mathematics while you are drunk. This kind of feeling. Just like you look at the numbers, you see the numbers, but it just doesn't even make sense. I was extremely tired, like I felt like this the entire 3 days. And I was just like tired. Not physically. Physically, I wanted to, I could do a marathon, I felt like. Obviously, maybe I'm not in the shape to do a marathon, but you know, you get the idea, right? Like I wasn't physically tired at all. I was just like completely mentally tired. I also felt just drained of like motivation at all. But then on Thursday night, I started to kind of like the fog kind of just like went away. And then I was like, okay, well, let's see what happens on Friday. Friday, wake up, I go to work, and it was just like I was back to normal, like before I was taking any of the supplements. It was very much just like difficult to focus, but that's normal, right? Like it was, there was no confusion anymore. And so now today, have the exact same feeling. It's just like, okay, I can do my work. I can force myself to do it a little bit, right? Like, but I don't know why I was so confused for those 3 days and just like completely unable to study or get any productive work done. Slightly concerning. Um, yeah, so don't know. Anyways, let's keep going. So, yeah, and I'm also doing this video here, like trying to kind of document myself of like, okay, well, this is what it's like without anything. And then I can also go back and look at my old videos as well. Okay, so what am I even doing? So the idea is I now want to have, we're going to be using Piper. Okay, so say I want to, and I can remember what we did last week. I want to point that out as well. Whereas last week, I was trying to look at the week before it, and I was so like confused. Like I couldn't remember it until the supplements started kicking in, and then it just came back. It really feels like, I guess one way that I might be able to describe it is I feel like there's a, it's funny because I'm going to be describing it in terms of hardware, but it really feels like there's an extra like memory bank and a like a high powered GPU and extra memory integrated into the GPU, right? That comes alive. And without the supplements, you don't have that. Like the knowledge almost seems gone. Like you're a different person. You really feel like a different person. Like I just don't have this anymore. And it's just my normal CPU or something, my slow CPU, but then here I have my GPU and extra memory where I learned the things, but when I don't have the supplements, all of a sudden it's just like gone. It's not there. I can't recall it. But after those 3 days, kind of like the lull, you know, and then you're back. Now those things that I learned on the supplements, I was able to I can recall it, right? Like the what I just described, the file systems and all of this. So now I can recall it. Yeah, I don't know. I was a little bit concerned, like, did I break my brain? I was that's what I was wondering. But then it came back, and I'm like, okay. So now I'm trying to process what happened and how I can actually, yeah, like, okay, what's this? What's this all about? Anyways, I want to, okay, I'm gonna say my file system is now successfully moved over, I now want to focus on doing what? I now want to focus on going the other way. Being able to get my device to go from text into speech using my microphone and speaker, period. Okay. All right. So let's start it off this way. So like right now, I guess I can describe a little bit more of what I'm feeling. Just like very dull, very just and this is normal, right? So this is not the thing where I was just feeling completely bad. But this is what I feel like before I took any of the supplements, and I feel it now. It's just like very dull, kind of lowish motivation. It took me a very long time to even start this video. I woke up a little while ago, but I was just like, man, I don't want to do this video. Kind of like that feeling, just like I don't want to do this. I don't want to do this. I don't want to do this. And then yeah, just like right now, I just feel kind of like this kind of feeling. This just um and when I was at work yesterday, I had the same feeling, just like constantly being distracted, obviously, and difficulty to start my things. But it wasn't like Monday, Tuesday, Wednesday. Monday, Tuesday, Wednesday, it was just like I would look at the thing and for example, I would look at this and I'm just like I can't even understand what this is. What? Oh, why is it telling us something? Okay, 1 terabyte SSD. What? Why? What? I can't connect that to the greater picture. But now, obviously, I can read this and I can just be like, okay, yeah. So it's just congratulating me that I got the 1 terabyte SSD and tells me that we're ready to keep on going, right? So I can understand the context now, whereas previously, over those 3 days, I was just like, I couldn't. I was so just like I felt like I was constantly about to go to sleep. Now I'm able to read it. I just like almost don't want to do anything with it. I don't know how to. Okay. And yeah, everything is just like not as clear. Like when you take the supplements, you're very clear of things. Um, hmm. All right. Anyways, so I'm just trying to like document as much as I can as well. Just understand everything. So you okay, so you have the perfect high-speed playground, okay, for AI audio, text to speech, and speech to text are computationally heavy. So we'll be running them on NVMe that will prevent stuttering, often caused by slow SD card. Okay, so that's not important because everything is going to be on the SSD. To turn your Jetson into a conversational agent, we need to bridge 3 gaps: hardware, drivers, processing, and logic. Okay. Alright, so unlike a laptop, the Jetson or a Nano doesn't have a built-in 3.5 millimeter audio jack. We're already there. We already have it, right? Like, we already got this plugged in. Most developers use a USB audio adapter or a USB microphone speaker combo. Yep, that's what we have. All right, the handshake. When you plug it in, the kernel uses advanced Linux sound architecture to create a device file. Okay. So check if your hardware is recognized. So we can do these commands. Let's a record minus L. Let's see. So, oh right, or back to here. So this is those different okay, I'm gonna come here, and then I'm gonna come here, and so we were doing stuff with like this thing, so audio.open, and we had to get all of these things like input device, and then channel, chunk, rate. So we found this, right? But the problem was, I think that each time something changed here. I forget what it was. Something was constantly changing. Was it like the actual card? Like card 2? Yeah, see, now this one is card 0, and I think that we had to capture that somewhere. I just can't remember where. So what is this A play? So now I guess when I do I remember that the device which it comes up on changes each power boot of my system, period. Within the Python, do I need to take account of this? Question mark. Okay, now, so I'm gonna come here and just record, or like copy and paste this. Okay, paste that into there, and then I'm gonna say for question number 2, we're gonna do this A play. I don't know what the A play command is, so let's try A play minus L. Okay, so that seems to be the exact same thing, right? Yeah, okay, whatever. So let's see, come up here. We still have the USB. No? Oh yeah, there it is. Okay. So for a component embedded engineer approach, you want a balance between speed and quality. Okay. Speech to text, the ears. So we're going to be using Whisper. Like that's what we already were using. This is the gold standard. It uses the NVIDIA GPU. Awesome. There we go. So the mouth, we were going to be using Piper, I believe. There we go. This is specifically designed for embedded ARM devices like the Jetson. It is incredibly fast and sounds very natural. Okay, so yeah, that's what we are going to be using, is this Piper. All right. So to make this work, you generally follow this data flow. So sudo apt get install. Okay. PyAudio, we already have this. Or sound device to handle the stream of bits coming from the mic. So we already got the microphone. So let me come here and to this one, right? And so we're not importing Whisper itself because we are invoking it, I believe. So I remember that we were not actually importing Whisper itself because we were going to be invoking it from the base C++, comma. I think that there were advantages to this, such as the actual processing time or RAM usage, period. My device only has 8 gigabytes of RAM, so I know that I need to be able to take that into consideration, period. This is how I did the listening part, period. Okay. So I'm going to come here, copy this, paste that into there. Alright, so why your new SSD matters. We don't need to, like, okay, great. It's working. We got it. So when an AI model speaks, it has to load massive voice tensors. Okay, mathematical representations of human speech. So voice tensors, okay. From the disk into the GPU. From the disk into the GPU. So on the SD card, you're going to wait 3 seconds for the brain to load. On the SSD, this happens in milliseconds. Your interaction will feel like a real-time conversation. But what if we can store everything in the RAM itself, right? If everything is in the RAM itself, everything fits within that 8 gigs, we should be happy. Okay, so I can say number 3, I will be using Piper. I guess the first simple test that I want to be able to get accomplished today is be able to take a hard-coded sentence and have that sentence come out to the speaker, period. Okay, so let's do that and see what we're going to be doing. It's great to see you're already... Okay, great. The other thing that I am going to do is I'm going to try to look at this video and see if I can see a difference between me here and me in some of my previous videos to see, like, okay, well, is there a significant difference? Alright, so it's great to see that you're using this Whisper CPP. Implementation is a pro level for an 8 gig Jetson. It bypasses the massive PyTorch overhead, saving you roughly 2 to 4 gigs of RAM that you'll need for AI logic later. Alright, so the dynamic device. In the embedded world, you cannot trust that a USB device will always be index 24. If you plug in a different USB camera or reboot the numbers shift, instead of hard-coding an integer, you should grep for the device name in Python before starting the stream. Okay. So always use name attribute. The kernel assigns these bases on the hardware's internal ID, which is much more stable than boot order index. Okay. So let's see. I want to make sure I need to commit everything, right? So git status, right? Nothing to commit. Okay, good. So now I want to do this thing right here. So I want to do def, and then get and delete, or like stop doing this. So get underscore USB underscore device index. Okay, so we're going to be doing this function here, right? And okay, we get Pi audio, and then get device count, okay? And then we return this I and close this, okay. Alright, so we are searching for this, like, USB audio as one of the items, right? Like, USB audio. Alright, I'm trying to... So what does this actually return? Is it... So I can do this P is equal to, and then Pi audio dot Pi audio here, and then we can kind of like, for I in range, we can print some stuff out to find out what's going on. So get device count. Okay, so we're just seeing how many devices were connected. Seeing how many devices were connected in this I need to go like this next time. There we go. So seeing how many devices were connected in all of this, right? Okay. And now I'm guessing that it's going to go each one by one here. Like this will be a list, a long list, and that list will contain elements, and this is going to be one element in that list. Okay. And then we go through and we get the information, which is probably going to be the content of that element here in dev, okay? So that's device right there. And then I say if this is within, okay, so it's like a dictionary actually. So this would be a dictionary. And we're going to say name here. Let's actually just come up to where it's the one that we want. So this is the name right there. Maybe this entire thing is name. But if this is in the value based off of the key name here, or if PS10 in dev name, then we close the device. We say, okay, we're good. And then we return that ID. Okay, so now I kind of see what's going on. Let's kind of do this. So we have the device, right? Is going to be equal to what was it? P dot get device info by index, and then we pass in the index there. Okay, so now we have the device name, and now we say if USB audio, let's what was it? USB audio if USB audio in device indexed at name Then they also did or something about the PS10. I don't know. So I don't know why P10S in device name. If this is the case, we want to quit out of this audio device. Okay, so P dot, was it terminate, right? And now return the index, okay? Otherwise, if we exited this, we P dot terminate as well, and then return null, none. Okay, I think this is what we were doing, right? looks good to me. Okay, so now what I want to do is I need to assign this to index here. So I should come here, record audio, transcribe. So before record audio, I want to do this find index, right? So come here, copy this, paste it into there, okay? And now, so this is going to get the channel device, but now instead of this input device here, I actually don't want to set this equal to 24. I want this to be a global variable. Okay. So I want this to be a global variable. So now is equal to this is going to be equal to none, right? First we set it to none, okay? And then what I do is here, I can still return I, but I want to set this equal to, so I can do like here, right, is equal to I. Now, the question that I'm going to have is, do I need this non-local, right? And, or global. So it has to do with memory within Python, right? So this one is going to, integers are defined like, if I just do input device equals I am going to be creating a variable in memory, a new variable in memory, and assigning this value to it. And that is going to be local. Okay. Come on. Please just go away. Okay. Awesome. Very good. Very good. Thank you for this. Close all. I hope that this doesn't close the... Okay, good. Okay, so this is going to be creating a new variable called input devices, which is only visible to this function here, which is not what I want. So I want to say global here. Okay. So this should now work, I think. So positional cannot appear after a keyword. Yeah, oh, is equal to, and then can I just say input put device index. Okay, like this. I'm not sure if this is going to work. Should we actually just try it? So copy this, right? And now I can come here and so let's see, I can do change directory into desktop and then see what's in here. So we're going to do Agentic AI, okay? And we want to go into example sound recording, I think. Yeah. Example sound recording. Okay, and then that should be good. Okay. So now if we do ls, we should see, okay, example 1. So now what I want to do is I want to use that cat command. So it's going to be something like, what is it? It was cat and then like piping it in. Here. Cat and then this example 1. It's this exact command actually. So like this, right? And then paste into here. Nope, actually, well, that's not great. Paste into there and then into file. No. And then command D. Nope. Control D. Okay. Oh no. Okay, so right. So all right. I did this problem in the last, I did this exact same thing in the last thing. So, I've run into a problem where I accidentally did Command D inside of my terminal, which makes it such that the terminal now is separated into 3 different windows, period. I want to be able to get it to be a single window again, period. I was trying to do the end of file when I was doing a cat. Okay. And then here, example 1.py. Alright, so your currently records here, downsampling. Yeah, so we did this in the last time. So we needed to downsample to be able to get it from the 48 kilohertz down to the 16 kilohertz, and the reason is because Whisper uses the 16 kilohertz. Okay. Piper is fantastic because it is a feed-forward model. It generates the audio faster than a human can speak it. And it runs natively in C++. Okay, so now, since you're on the Orin, you can download the standalone binary. Okay, so, right, we're going to have to do that. And then we need an Onyx model and a JSON config. Okay. I don't know what any of those are. We're going to need to... Okay. I remember last time we also had a problem with this. It wasn't this specific one. It was... I remember when we were trying to download the Whisper, first you told me to go to a GitHub to get the files, but then we were running into a problem where the GitHub didn't exist, and so I needed to use some other method, period. But now that I'm saying this to you, comma, I am thinking that maybe it wasn't Whisper, and actually it was one of the file transfer system which we were doing from microSD to SSD, period. What was the step which we did for Whisper to get it to work, comma, and are we doing the exact same thing for the Piper, question mark. Okay, that's this one. Number 3 is going to be to, obviously I know that we're getting it, and can you explain what we are doing in this and what the end result is, question mark. So obviously we're going to this like GitHub page, right? So we're doing a wget for this GitHub page, and it's like compressed, and then we're decompressing it, okay, with some flags, and it's going to live inside of this Agentic AI folder. But then, like, how are we using it? Okay, so this is another one. What's happening here? Number 4 is going to be what is happening here, and what do you mean by a .onnx model, and why do we need a .json configuration file, question mark. Alright, so the hard-coded speech, here's the Python logic to take a string and pipe it through Piper binary and out. Okay, so what were we on, 4? I'm gonna say 5. I changed my Python code to try to identify the device dynamically, comma, what do you think of it, question mark. Do you see any problems in my code, question mark. Okay. So copy you and paste you there. All right. So now with this, we're going to be creating another, this one is going to be, what am I doing? Audio operations, recording here, sound recording. So anyways, I'm going to be creating a new one here. So audio transcription example.py. Okay, so now we're going to be doing something very similar. So let's just kind of write it out and see where we get problems. So we're going to do import and then sub process. Okay, so now Piper path is going to be equal to Piper, okay. Adjust according to your extracted folder, whatever. And then I'm right in the way, so then we're gonna do this. Okay. Let me move this down so that I'm not in the way anymore. So model path is equal to en, so English, US here, and then LESSAC medium.onnx. Alright, so I'm thinking that this is a medium size, and we also, because we want to do it in Chinese as well, we might need to do a Chinese one here. but we'll figure all of this out later. Okay, so now we're gonna do def is speak text here, so print speaking, sure, text. Okay, so all right, let's see what's going on here. So we pipe the text into Piper. Okay, pipe the text into Piper, and pipe Piper's raw output into a play. We use P, or so minus P uses the P10 USB device for playback. Okay, so we're probably gonna have to dynamically put that as well, right? So the P10 USB, whatever, and then subprocess.run. Use the D target here card directly. Okay, let's do this first. So command is equal to F echo, right? So okay, so we're echoing text. So we're doing the echo command, and then we're literally piping this. Okay. So we're creating this command, which is just going to be a text, right? So it's just text, but this command is going to be done within the terminal, and so then we're doing like subprocess run. So we're actually running this block of text in the terminal, which does a command. Ah, got it. Okay. So now we pipe this Piper path, okay, and then we do m. Okay, so we're gonna do, and this is just a command to Piper itself, right? So to this executable, or okay, we'll figure that out later. Model, right, is model path, okay. And then output raw, and a play is R. And then 22050 minus F S16, whatever that is, LE minus T raw minus D hardware 0,0 here. Okay, I think that we messed this up, right? There we go. Okay. So now we run that in the subprocess. So subprocess.run, and we want to do the command, and what was it? Shell is equal to true. Okay. So we're going to be doing this. Oh, man. Oh, I lost my questions. Good. So thankful for that. Okay. The first question is, I accidentally messed up my terminal because I did Command D instead of Control D. I was initially trying to do the end of file token on the but then I ended up separating my terminal into 3 distinct parts, period. How do I get out of this, question mark? Okay, that was question number 1, and then question number 2 is, okay. I remember that we did something where the GitHub was not available and we needed to use a different method, period. I think that this was actually for the transition from microSD card to SSD, period. But now I'm thinking about how we did the process for Whisper, period. Are we using the same process that we used to get Whisper with this Piper now? Question mark. Okay, that was question number 2. Question number 3 is, oops. I'm trying to understand what the commands we are doing for getting a okay. Now, what is a .onnx model, and why do we need a .json configuration file? Question mark. What are we going to be doing with them, and how do they work? Question mark. All right. So now, do we have a question with this? We'll figure that out later. Okay. Question number 4 was going to be this one. Oops. Here is my updated version for the listening microphone. I changed it to be dynamically looking for the device. Comma, what do you think? Question mark. Do you see any problems? Question mark. Okay, so let's do that, and then I guess if I was a little bit more like curious or something, I need to. So, something that I've been thinking about is I really need to hone in on those things that I do a mistake on multiple times, like this Command D. Why did it happen? How did it happen? How do you fix it, right? The other one is, oh, I was thinking about it, but I've lost it. Let's see if I can jog my memory up here. Do I see anything? Do I see anything that is jogging my memory? Not really. Oh, the cat command, right? Like, I need to go in and understand, like, okay, why. So, I remember going and investigating the pipe versus the cat, or the like, carrot one. So, I need to kind of go back because I've stumbled over that exact same concept like 5 times in my videos, separate times. And each time I'm like, oh, how do I do this? And I have to go and relook it up, but I don't actually I don't go and take, maybe even taking 10 minutes to really understand the concept will make it such that I don't need to spend 30 seconds 10 times over the course of a month. right? And just keep continuing this, but never actually face it head on. Okay. Anyways, come here and Command W to close the pane. So I'm gonna come here and do Command W. Terminate, sure. Oh, that's not what I wanted, but okay. That is not what I wanted at all. Anyways. I'll try, you can go. Yeah, Control D is what I want. Jetson. Okay, so now I'm gonna come in here and change directory into desktop and agentic AI and example sound recording. Okay. So now I should be able to do this and see that I have this thing that says, yeah. All right, so Python 3 example 1.py. Let's see. Hello, can you hear what I am saying? This is my little test. Okay. Finishing. Good. We were able to dynamically get it to work. Okay, so we just confirmed that this actually works. So let me actually come in here and get add here, git commit, and I'm gonna say added dynamic query of USB device for speaker microphone to fix problem of device enumeration. I don't. Okay. To fix problem of device enumeration on new startup of NVIDIA Nano Jetson, period. Okay. All right, there we go. And we are good. Okay, cool. So now, is this the same process? Yes and no. The why. We are avoiding the heavy Python libraries to save my RAM. Slightly different. For Whisper, we compiled the C++. Yeah, so, okay, I was kind of remembering that this seems a little bit off. Like, it just doesn't seem like we're doing the same thing, which is true. For Piper, we are downloading a precompiled binary. Okay, a precompiled binary. Okay, well, actually, I was just about to ask that question because precompiled would imply that if it's precompiled, that would imply that it is for my specific machine, right? But the answer is yes. Since Piper is already optimized for this ARM64, we don't need to compile it ourselves. We can grab and execute it and run it. Okay, that makes sense. I see. So that's why the process was a little bit different. Understanding the O in an X and the .json. This is a core concept in AI development. All right, so O in an X file, Open Neural Network Exchange. Think of it as the brain synapses, okay? When a researcher trains an AI like Piper in a language model like Python using PyTorch, the resulting file is messy and huge. Okay. O in an X. Universal export format. It takes the complex brain and flattens it into a higher performance mathematical graph that can run almost any hardware without any Python. Okay, so it's like a neural net or something. I don't know. So the Onyx file is just raw math. It doesn't know what sampling rate the audio should be or what phonemes, speech sounds it is supposed to produce. .json tells Piper software, hey, use this specific math file, but make sure the output is this specific hertz. Okay. Here's how to map letters to sounds. Okay. So code review here is excellent. It makes this one small bug here. You created P, but in record audio, you create audio is here. The risk. Sometimes when one audio instance closes, another one opens. The device indices can shift, though rare. Okay. So it wants me to pass it in here. Just do you remember when I said I don't have much motivation right now? Oh my gosh. Okay, so yeah, this really does kind of seem to be what I was talking about in terms of like normal. Like I can do it, right? I've made progress today. I can understand what's going on, but I'm also just like kind of dragging my feet along with it. It was very difficult to start. I'm trying to force myself to keep going. I really want to just go out for a walk, right? All of this, and when I see something, I'm not like, okay, let's dig into it. Let's look into it. Whereas when I have the supplements, I'm just like so natural to just like I'm like. So first off, obviously, just really relax. And then you just say, okay, let's go. Oh, interesting. So here's this. Okay, let's do it, right? And there's no friction to even start doing it. Whereas right now, I look at this, I'm like, I don't want to start. I don't want to do that. I don't want to do it. Right? Whereas when I have the supplements, I'm just like, oh, okay, interesting. Let's just go do it. Let's go do it. And I also remember when, so I had been taking the supplements for a little while. Um, I've been doing it for 2 months now. Um, and I remember thinking like, oh, what was even the issue? It's just so easy. Just do it, right? Just do it. Just start doing your work. Like I must have just been like royally lazy or something, you know? And then when I stop now, I'm just like, it's a weird thing. Like, why is my brain just like so lazy? Just doesn't want to do it. But I feel the emotion, right? Like, I don't know. Okay, anyways, let's now that I've made that little speech, let's like force myself to do it. Or we could just do it later. Or it doesn't matter because look, it said like we don't need to. It said like it's rare. So it's probably gonna be fine. Alright. So let's just do the Piper. Alright, so I'm gonna come here, I'm gonna copy all of this. I'm gonna come into my terminal, and now I'm gonna do the same cat command. And I'm going to say like cat, and I'm gonna go here, and I want to cat it into let's see, audio transcription, audio transcription.py, right? Okay, and I'm gonna paste that, and then Control D. Did it get it? There we go. Okay, so now I'm going to cat and then audio. Okay. All right. So now what would happen if I just did Python 3 audio recording.py? Oh, well, that's kind of stupid. It's we didn't even do anything. So let's I need to do what? I need to go like example text is equal to hello. My name is Timothy Grant. Okay. And then okay. Speak with example text. Okay. So we need to actually edit that, put it into here as well. So let's do that. What was the command to just delete everything here? Okay. Once again, try to figure out, anyways, whatever. Vim of audio. Okay. We're coming here for insert, and then we're just going to do this ourselves. So in here, and I'm going to say example text is equal to hello, my name is Timothy Grant. Okay. Then I want to do speak with example text here. Okay. Wait, quit. All right. But we now also need to remember to get the Piper, because we haven't done that yet. And we need to have it at the right location. So let's download a voice. So we're getting this like executable here, right? So Agentic AI folder, and then we come here and get this. And where is all of this being actually like stored? I still feel like I should have gone back and actually looked at the other one. Okay, let's come here. Let's just do it. Let's do it. Come on. Okay. So, let me take some coffee. This is what I mean. Just like I can do it. My brain is not confused. I understand the concepts. I but it's not like those 3 days where I just would not be able to do it. Now I can do it. I do have the capacity, the capability. My IQ is there, right? Like previously I felt like my IQ was just like I didn't have one. Like it really felt like you were drunk, where you would look at the concepts, wouldn't even make sense. You would look at something and just, like you couldn't even understand it. Now it's like, okay, well I can understand it. It's really difficult for me to actually focus on it, but I can force myself to focus on it for a little bit, and then I kind of just, like don't want to do it anymore. But I can force myself to, right? Like that's kind of I can force myself, and I can understand it if I force myself. Just continuing to force myself is kind of difficult. All right, continuing to just make more and more observations of myself based off of like right now, completely not on any of the supplements. Whereas I feel similar to what I did before I ever started taking the supplements. And then, okay, when I'm on the supplements, then I'm just so clear, everything just flows, and I don't even need to like try to force myself. I just do it. And I'm kind of like in control of my own actions, where I'm able to say like, yeah, I want to accomplish this, and then I just go and accomplish it. It's a very weird feeling to be able to just like flow and accomplish something. And but also like you understand things better. Like it's more clear. Like you can connect concepts better. And an example of this is like LeetCode. When you're doing LeetCode, I will look at the concepts and I will just be like, oh yeah, well this would make sense because you would need to be backtracking is explore all possibilities, and so this question is asking me to explore all of the possible permutations of the problem. So therefore I need a backtracking solution, right? And what is the data structure that it's operating on? Okay, well it's this whatever, like a string. Okay, well then I'm going to then be applying my backtracking to the specific type of problem, like data structure that they gave me. So I need to process. So I have the template of the backtracking. I process the data structure here. And what am I going to do? I'm going to include or not include. Okay, well, I know how to do that. And now, well, okay, I need to be able to have some way to keep a record of the current path. And then that's where I went and looked at, okay, well, hold on. I've been struggling with this thing of local, right, or non-local, global, uh, all of this for so long. And normally, when I was doing LeetCode, normally what was going on is I would go on LeetCode or start a problem, right? And I would always get that wrong. I would try local, or I would try the non-local, I would try the global, I would try the, or sometimes I wouldn't even need to put the local or non-local there. And I would just get it wrong and then change it and then get it right and then never actually take the time or have the initiative to actually go and search like, okay, well, what was actually going on? What's the underlying cause of it? But then when I'm on the supplements, it's just like, oh, well, I got this wrong. Why? let's check it out. Let's actually get to the bottom of it. And then I realized, oh, Python, right. You have the mutable versus immutable object types. So for immutable, these are the ones that Python creates a new, it allocates a new section of memory each time you update it, because you are literally creating a new variable. So integers, strings, all of these are immutable types, floats. And so then you have mutable, which you're allowed to change, right? Changeable. And those mutable types are um, are going to be like lists, for example. That's a mutable type. And that, if you change it, it occupies the same block of memory. So you're not actually changing the actual variable. Um, you're just changing the contents of it. So then that connects to the global and the non-local, and when I would not even need to write any of those keywords, because what would go on is if I have an integer that I create, like as I just said up here, the equals, where is it? This equals I'm actually just I'm creating a new variable right here. Creating a new variable and assigning it to I, and it lives within this scope. And so no wonder whenever I would come into the outside function, or after I would do a helper function, right? Helper function here. And I thought here, oh, well, I defined it right there. By the way, as you can probably see, this is coming from a background in the language of C, where if you define something up here as a global, and then you use it here, you use it here, you just like assign it here, there's no problem, right? So that's kind of where my confusion sprung from, or my, not confusion, but misunderstanding, or it, it was just something that I never got to the bottom of. And it just kept coming up and up and up and up, and I would just almost ignore it and not go to the bottom. And now that I investigated it, I say, oh, okay. Now I get it. That's why I need this global as a way to say, hey, helper function, there's this variable here, and we want to like have that be the same variable. Whereas if it was a list, for example, we wouldn't need that because it's mutable. It's the same, it occupies the same thing in memory. So now why do I go on that tangent? Because previously I just kept running into the exact same problem over and over and over, and I never even thought to face it. But then when I have the supplements, it's just like natural. Just like, oh, well, okay, well, let's look into it. Oh, that's why. Oh, okay, I see. And every time, and then maybe I run into another problem, and I then say, oh, okay, well, then I thought that I had a correct understanding, but I need to change it again and make it even more accurate, right? And it just like comes so easily. So okay, well then I understand that within the backtracking, and then I say, okay, well now I can put all of the pieces together and everything just makes sense. Like the concepts connect. Whereas like right now, when you don't have the supplement, it just feels like it's difficult to actually connect everything together. But as you notice, like right now, I have that in my brain, that even though I learned that while I was on the supplements, I'm able to um, recall it. And I kind of understand more about the backtracking. Whereas what I was saying with the GPU, with integrated memory, it feels like normally I just have this slow CPU, which is my normal brain, but then the GPU with integrated memory, now it still feels like this GPU is not accessible. But the memory, I kind of feel like my CPU does have access to the memory that I am able to actually tap into what I learned. Um, Whereas previously, like when I take it and then it completely wears off and then the next day, that one, it seems like the memory is just also just like not even there until the supplements come back in and I'm like, oh, here we go. And then I just remember everything again. So now, okay. So now I have my CPU, which doesn't seem to that's my current brain. Then I have my GPU and then it's not an integrated memory anymore. The memory is still there, but so right now I'm able to communicate with the memory, but it's only my CPU to the memory. There's no GPU. Now, then when I take the supplements, I have my CPU. It's connected to the GPU, right? And uh like there it's a three-way connection. CPU to GPU, GPU to memory and CPU to memory. But the GPU, because it's so fast, it's just back and forth from memory to the CPU, right? Like it just processes everything so quickly. You're able to connect everything. Then once you have taken it and then it wears off, then it's just your CPU. There's no GPU or memory. You can't even remember that. But then you're also in that fog, that really just like real fog. You cannot think. It's like you are like about like you just woke up kind of feeling that you just woke up after a very bad night and you're just like you can't focus on anything. But then that lasts the entire day. And that was day 1, day 2, day 3, and then day 4 is when it stopped. And now from day 4 to 5 was Friday, right? And now today is day 6. I'm back to normal, but I just have my slow CPU, but actually connected to the memory. And I'm not in that fog. More and more, just taking observations, trying uh, to recognize and observe all of this stuff. Yeah. Anyways, oh man, we still have to do this. Oh. Okay, come on. All right. So there's a small bug. Okay, great. Where's the small bug? Look at your record audio function. Come here, record audio function. Stream is equal to audio.open. In here, you create local this, okay. But in record audio, you create a new one, okay? Sometimes when PyAudio instance closes, another one opens, the device index shifts. Okay, pass the index directly as a parameter to keep your functions pure. Okay. So okay. Record audio, and we're gonna have the device index here. And then but I still create it right there, right? I'm still creating a new one though. I'm still creating a new one, so it doesn't even matter. Like, it doesn't make sense. Let's just that's not okay. Let's just do this. Can you tell me exactly what's going on here? And in specific, I want to know about where these files actually are going to be and how I am going to invoke them from within my Python, period. So like, yeah, I guess that's something. All right. Fine. So yeah, like this is normally how I would be doing engineering, is just like forcing myself to keep going, keep studying, keep moving forward. And I did this my entire it took me a very long time actually to get my engineering degree because I was working full time and going to school part time. But I would just like force myself to do this. And this is the exact feeling that I had every single day when I did engineering, was just like, I really don't want to do this. Let's take one more step. Let's go. And now when I have the supplements, it's just like so natural and it's fun too. Like, I feel like I'm learning so much. I'm just like, oh, this is amazing. I'm able to just so easily do things. It's such an amazing feeling to be able to be kind of in control of what you do. And like, I'm just gonna learn. And there's nothing like, no barrier. And I should also preface this by, I mentioned it in previous videos, but obviously everything is completely legal. It's under the like supervision of a doctor, right? So I do want to put that out there as well. But I am always trying to um, take observations of myself, and obviously uh, I'm a person that's able to observe my own subjective experiences, and I'm trying to collect as much data, understand what's going on within myself, and then I can also relay that up to him and say like, hey, these are the experiences that I'm having. What is this normal? Is this like what's actually happening? So I do want to make sure that I preface it with that. And then yeah, so the specific like supplement is and I'll have to like separate this a little bit. So it's Vi, and then the other part is Vance. So put those together, and you can see what it is. And so I started off on 30 milligrams, and now moved to 50 milligrams. So yeah, that's the when I'm talking about that. But I know YouTube is a little bit sensitive towards that kind of stuff, but it's not like their actual thing is like you can't do or you can't talk about the recreational, which is not recreational. It's under the supervision of a doctor, so it's not that. But anyways, I'm always a little bit concerned about like YouTube's specific policies. I want to make sure that I'm in alignment with making sure that I follow what they want me to be talking about. But yeah. So what was I even doing? Oh, we were gonna figure out where these things live, right? Okay. So when you run wget and tar, the files in your current working directory, wherever your terminal currently sits, for a clean engineering setup, you should be in a dedicated folder like this. Okay, after running these commands, the folder structure will look like this. Got it. Okay, so agentic AI, and then we're gonna have all of this in here, but I kind of want to make this into a separate thing. So I'm gonna say something like this actually. So I'm gonna come in here and do this ls. Oh, did we freeze? Yeah. Okay, so we froze here. It's fine. We will. Okay. There, so that way I can click on it, but this thing isn't in the way. So I actually want to come up one level, and I want to go in and make directory for sound processing. Okay, sound processing, and now I want to go into sound processing, and from here I want to do these commands. Okay. So from within this, I want to come in here and do this. Okay, so let's try it, right? Okay. So we are downloading this executable essentially. Okay, so now I want to come in here, ls, and we should see, awesome. So now I want to unzip it, right? And this is going to be the unzip. Okay, like this. Okay, now ls. All right, so now we have that piper right there. Awesome. So now these two things. Okay, so let's see what those are doing. Okay. So it looks like I'm just going to actually get the Onyx file and the configuration file that it just downloads it. So let's try that, right? Like this. Okay. Okay, let's do this ls. here, and we have this Onyx and JSON. Okay, so now it does match this kind of thing, and I see that we have this like SO, the shared object file, okay? And this Piper, the actual executable binary. Okay, so this is probably written in the C++, right? The Onyx and JSON files work as a pair. When you run Piper, you point it to the Onyx file. Okay. Piper is smart enough to look for a file with the exact same name ending in JSON in the same folder. The Onyx contains the neural network weights. Neural network weights. The JSON contains a phenome map. I feel like this stuff is super interesting, and I should have more motivation to like dig into it, but I just don't right now. Oh my gosh, I feel like it's super interesting, and I want to understand like what's going on, but okay. Invoking from Python the shell pipe strategy. Since Python is a standalone C++ binary, we don't import like a binary. Instead, we use a subprocess pipe. This is a classic Linux pattern where you pipe the output of one program into the input of another. So, again, I should be digging into this of the piping versus the caret, and it also solves my other problem that I just mentioned that I wanted to do, which is the cat caret into an execute or into a file. I think the pipe one is from one process to another process, whereas this one is you take std out of the first thing and put it to a file. But then that gets into the question of like, okay, if I do that, I do cat, but no arguments, and then this to a file. Why does it give me that screen where I can just put stuff in? Like, is that part of the cat binary executable or what? Like, who does that? Who's doing it? You know? Okay. But anyways, so now we're going to need to voice model, subprocess run, no memory bloat. Okay. So I actually do need to change some things, right? So I need to do pwd here is going to be home Timothy. All right. So I'm going to come here, I'm going to copy this, and I'm actually just going to paste it into here. So this is sound processing, right? So, okay. So I'm going to come here and I'm going to say Piper path is equal to here. So sound processing, and I want to hit Piper, right? So I want to come in here and I want to hit Piper. Okay. Piper. So go into Piper and hit that executable. Now, this is going to be an absolute path, right? So that's fine. Oh, right, we need hashtags. Okay. So then this is going to come in here and it is going to invoke the text for this path, or Piper path, model path. Okay, model path here is, I am going, so it's this Onyx. I think I'm going to need to do the same thing here. Sound processing. Okay. Like this, right? And sound processing here has this Onyx. Okay. So now I'm going to come in here, copy all of this, and say, how does this look? Question mark. Like that, and see if it does it. Which is smart for embedded, it won't break. However, if you hit run hardware reality to ensure your USB speaker is sitting at this, right? So it's one more thing of just like, okay, card 0, but sometimes A play. Okay, so let's do this command. Okay, let's do this, right? And do this, and now copy the output and just paste it in. So copy you. Okay. Alright, so like we did with the other recording section where I needed to go and dynamically do a command to get the index of the device, comma, do I need to do the same thing with this one? Question mark. And what does the HW:(x, y) actually mean? Question mark. Can you show me how the Linux command that I did actually links up? Question mark. All right. So if you see here listed as card 0, device 0. Okay, card 0, I see card 0 here, device 0 there. Okay. So let's just go and check. It should be, I think it was 0, 0, right? Card 0, device 0, so it should be okay. Because that's what we did. Right there. Okay. Double quotes. In your command string here, this works great for simple sentences, but if AI ever says something with a double quote inside of it, the Linux shell will get confused and crash. Okay, so to make it more robust, you can use this quote to sanitize the text. But for your current, okay, so it's fine. Since you just extracted, it might need permissions. Okay. Okay, yeah. We can do that. For Piper, that makes sense. Alright. So I'm gonna run this. Okay. And now I want to go up a level. Okay, what's in here? Sound example, sound recording. Okay, and then check in here. So I want to cat, right? And I want all of this. Okay. So I'm going to cat this into my audio transcription. Yes. here, okay? Command V, and now Control D, okay? Control D. And now Python 3 audio recording. Okay, let's see if we hear something. Obviously, we did not hear anything. Okay. Here is the output when I ran my command, comma, I did not hear anything, period, when I ran my program. Okay. Okay, means APlay tried to send a mono channel 1 signal to here, but your USB device is stubborn and only accepts... Okay, I remember running into this a little bit. When we were trying to do the microphone portion of it. Okay. Fixing the channel thing. Piper outputs mono audio by default. To make it work with stereo USB, we'll have to tell APlay to plug into a stereo socket. By doing this, we do this by adding the C1 flag. Okay, so I'm just going to update. I'm just going to copy and paste this, and we will do that later. Or we'll investigate it later. Okay. So come in here and do V right there, right? Okay. I do need a dynamic lookup for APlay. Yes. Okay, we'll do that later as well. Why the program looked like it worked but was silent. So copy all of you and then come back into here and do the exact same thing. Okay, well, it's frozen, but okay. Here, paste you, Control D. Okay, then come back up here and do this audio transcription. Let's see. Same thing. Okay, so cat audio transcription.py here. And make sure that it has that. Okay, good. So I will do this and paste it into here like that. I still do not hear anything, period. Okay. Oh, do we not do this? Like, what's going on there? I don't know. What is this re? What is import re? What does that mean? Replay or something, maybe? Okay, to this, what's going on here? Update your Python code to this, but we're still doing the... Okay. Anyways, raw mode, sending mono. Okay. volume check. Well, I'm not going to do the volume check right now because we're getting an error, so that indicates that we're actually, that the problem is the error, or the error. If we were, okay. If we were getting a problem where we were supposedly seeing no error but not hearing the or hearing the voice, then maybe we could say, oh, it might be the speaker volume. Oh, but if we're getting an error, then we need to solve that first. Okay. What's this? Oh, is that cat? Okay. Well, now maybe we can try this. Okay. Well, I saw it. The thing changed. Like, it looks brighter now. A little bit worried. Like, I don't want it to, like, blow my ear out or something. Okay, let's try it again.
Hello, my name is Timothy Grant.
We got it.
Hello, my name is Timothy Grant.
Oh my goodness. And let me actually go in here and this, let's set it, instead of 100, let's do like 50. 50. Here we go.
Hello, my name is Timothy Grant.
Okay, still a little bit louder. Let's do 30. Okay.
Hello, my name is Timothy Grant.
Here we go. Oh my goodness, we got it. So on that successful note, I think I'm going to end this video, and in the next video what we are going to do is I'll need to be able to take this and we need to there's a couple things that I want to do. First off is we need to be able to get this to speak both English and Chinese. The other thing that we need to do is be able to see if we can change the voice model to make it sound different for like, oh, can we, how do you actually make it sound like, oh, this person or that person, right? Like, I think it would be super cool to be able to eventually model it as like my voice, and maybe I can have I don't know. That would be pretty cool if we can model it as my voice, put that in there, and be able to have it talk as me. But that's going to be way out into the future. But kind of just understand, like, how do you get different voice models, and how is it actually connecting everything together with the JSON and um, the Onyx weights. Uh, so that's one thing. The other thing is going to be what were we actually doing with this? Like, there's a lot of stuff here, and obviously this needs to change because it needs to be dynamic, so we need to add that as well. The other thing is we need to take this, kind of put it together with the microphone. So we need the microphone and the speaker all to be working together. So, and I think what I'm going to do, because I don't quite have the record button yet, I'm just going to have it where I can like press on the like keyboard, and it's going to be just like start recording. So maybe I do like whatever the program is running, I do S enter, right? And then that will make it where I'm able to listen, and that records the audio, sends it to the LLM. The LLM responds back to me, and then sends me, and then like does the speaker the voice back. So we need to understand a little bit more about this speaker part. Then we need to integrate the speaker and the microphone together with the LLM so that we have all three components working together. And then from that, we will be able to go and try to make it more interesting. So building out some tools that we can invoke from our LLM, being able to get it to be in both English and Chinese, and just finding new ways to move forward in that. So that's kind of the direction I'm going. And I think today was a very successful day. I'm very happy. Look at that. That's amazing. This is great.
Hello, my name is Timothy Grant.
There we go. Okay, so anyways, thank you for watching this video. If you liked it, subscribe. I would love to have you along on the journey, and we are going to continue on this project. We're going to make it better and better and see what we can learn along the way. This has been a wonderful project for learning. I've absolutely been able to like gobble up as much really interesting and useful information as I can. So I've been enjoying it, and yeah, so subscribe if you want. If not, that's okay too. Have a wonderful rest of the day. Goodbye.